And there are also other topics, but I think I do not have time to talk about it. The wavelengths, maybe you can read materials yourself. There are only very few commands you can use. So now let's go back to the last section. The rough set problems. We have talked about the classical set. We have also talked about the fuzzy sets. There is yet another set which is quite useful in research, which is called the rough set. So now let's see what is a rough set. In mathematics, set is a very solid concept. It has very solid boundaries. If an element of A and the set of A, we can say there are only two relationships as I told earlier. A belongs to A, or A does not belong to A. However, in applications, if an element is somewhere around here, A, and also we assume that A is not accurately measured, then sometimes if we measure A wrongly, we may say that A belongs to set A. If we measure A as somewhere here, since the measurement is not always very accurate. So in this case, we may measure the elements wrongly and get the wrong result in classical set theory. So we have to extend the idea of sets. We should not use the very solid boundaries. We have used some kind of soft boundaries. Then we can introduce two concepts. One is the so-called upper approximation of A. We can have also a lower approximation of A. For upper approximation of A, we mean that there is an element, however, this element possibly belongs to set A, not definitely. So this kind of set could be slightly larger than the original A set. We call it an upper approximation of A. And for another element, if the element is around the boundary here, then if we measure the element wrongly, we may say that this element may not belong to set A, which is of course a wrong conclusion. So we have to introduce another set, the lower approximation, which means that in this set, the element, no matter whether you checked it wrongly or correctly, it definitely belongs to set A. So there is another set, we call it a lower approximation set. So there are two sets. One is the element possibly belongs to set A, we call it upper set. And another set, the element in the set definitely belongs to the set of A, we call it lower approximation set. So this kind of idea is called the rough set. We do not have very solid boundaries in set A. And between these two sets, if we take the set difference, we may define the so-called boundary set. If we take the difference between the upper and lower approximations of A. So these are the theoretical introduction to rough sets. So just to tell you what are the rough sets. And now I will give you two interesting examples to show the application of rough sets. Rough set is very useful in the so-called information system reduction. So before we talk about the information system reduction, we will talk about what is an information decision system. Suppose you have a very large database, where the database stores a lot of different things. One thing we can consider as one condition. So we have condition 1, condition 2, and condition n. And from the conditions, we can draw conclusions from them, like decision. And here we can consider such an example. I do not want to talk too much mathematics, just to give you an idea what is the conditions and the conclusions. Suppose we are trying to detect swine flu. So swine flu could be the decision, the diagnosis. We want to detect whether a person suffers from swine flu or not. And usually in hospital you have to measure a lot of different things. For instance, blood pressure, temperature, WBC and something like that. You have to measure maybe 10 or 100 different measurements. Which of the measurements are related to the diagnosis of swine flu? We need to dig out from so many conditions which one might be useful in the diagnosis. So for this measurement, we call them the conditions. Maybe we have a very large database. And then we call this one the conclusion. And in mathematical terms, for this column, we call it the one of the conditions. This one is the second condition. For instance, we have 10 people, and we measure blood pressure as the first condition, and we have blood pressures of the 10 people all listed here. And then we have to measure the temperature of each of the subjects. We can have another condition. And WBCs, we can have another condition. And also we have to measure whether the people cough or not. We can have yet another condition. We may have a lot of conditions, and we can represent them by columns. And then we have decisions. For this example, we have only one decision. Swine flu or not. We have 1 or 0 to indicate whether the people suffer from swine flu or not. So we have a decision table like this. So with the use of log set, what we are trying to do is to find which of the conditions contributes much to the conclusion. In this case, we can omit many of the items which is not quite related to the diagnosis. So in this case, we will see that we can represent this item by a C matrix, and we can represent the decision by a D matrix. So now let's